here we have another inverse function, y equals sine of the minus 1x. Now that's sine of the minus 1x is not equal to 1 over sine x. It's not. This is a way of writing the inverse sine, the angle whose sine is x. So this is the angle whose sine is x. Now don't forget x would have to lie between -1 and +1. So this is the trig ratio, and this says go back and work out the angle that has that x value for a sine. So we can't just bring this downstairs and go that 1 over sine x and then find the derivative of that. So we can't do that. So that's the first thing. So we're going to use our little template, 3-step template that we've worked out for finding the derivative of inverse functions. And the first step was to rewrite it. So if we've got y equals sine to the minus 1x, we can say that x is equal to sine y. That's the first step. Second step is to find the derivative with respect to x. So we go d dx of x equals d dx of sine y. And we can evaluate each of these derivatives. Derivative with respect to x of x is 1 is equal to, now this once again chain rule, so it'll be d dy of sine y times dy dx. Derivative of sine is cos y times dy dx. And the third step is to get dy dx by itself and then the other side in terms of x. So we've got 1 equals cos y dy dx. So 1 on cos y equals dy dx. Okay, now we've got to get this in terms of x. If we go up here, we've got x is equal to sine y. We've got cos y here. So is there a link between cos and sine? Well, we know the Pythagorean identity. It says that sine squared y plus cos squared y equals 1. So there is a link between sine and cos. So what we're trying to do here is get this in terms of x. We've got cos y here. So therefore we can get cos squared y by itself as 1 minus sine squared y. And so we can say that cos of y, take the square root, and when we take the square root we get plus or minus 1 minus sine squared y. But sine of y is equal to x, so it'll be plus or minus the square root 1 minus x squared, because sine of y is equal to x. Sine y there must be, sine squared y must be equal to x squared. So we get dy dx equals 1 over plus or minus square root of 1 minus x squared. Alright, so we've got two answers for dy dx. Can there be two answers? No. The inverse function, if we were to look at what the graph of y equals sine to the minus 1x looks like, it will look a little bit like this, where this is minus 1 and this is plus 1. So that's y equals sine to the minus 1x. It goes from minus 1 to plus 1 because x has got to be the value of what the sine of the angle is, and the sine function oscillates between minus 1 and plus 1. So the inverse function, the x values must be between minus 1 and plus 1. And if we look at this, the gradient everywhere is positive. So in this instance we can reject the negative and we can then say that dy dx is equal to 1 over, just take the positive 1 minus x squared. Alright, given that y equals sine to the minus 1x, the inverse sine or arc sine of x, we can say dy dx will just be the positive one because the gradient everywhere along this graph here is positive.